A very warm welcome and to a complimentary webinar. So we are going to be talking about 5G features, standardization, and status. So before I get to that, let me give you a quick short introduction to award. We are the technology leaders for training. So we are in the business of training and we lead this domain from a training perspective. Just to give you a quick insight, we have around 100K plus students. We have gone through our trainings. And while that said, in 5G itself, we have had more than 11K students going through our trainings. At the same time, we have seen 98% of our attendees always want to come back and attend some of our follow-up classes or recommend our classes to others. And also our SME scores have been fairly well respected. At the same time, we are the best. We are one of the best companies to work in Texas. So we are based in Texas. We are out of Dallas, and we are into technology training. The breadth of the domains which we cover is all along from wireless to IP, and you can talk about slicing, automation, 5G, VoLTE. It covers the whole, encompasses the whole technology area of the industry as such. We have most of our clients are all the carriers as well as the OEMs in the industry, not just in the North American market. It's global portfolio which we cover as such. We are the preferred technology partner for Mobile World Congress. For the last few years, we have been actively part of their Mobile World Congress training forte, and every year we do participate, and we are one of the lead technology training partners. At the same time, CCA, we are part of them, part of their portfolio also as part of the training partners. So we are preferred training partners for both Mobile World Congress as well as the CCA. While that said, why are we the leaders we feel in the industry from a technology training perspective is because we are very versatile and flexible in the way we impart our trainings. And that said, we have multitude of mediums in which we impart and communicate with the students. Just to give you a few insights, we are saying we have instructor-led trainings where we have an instructor either on-site or on the web. We have e-learnings, which is basically self-paced, which is the way to go as we go forward. We understand the balance between the two. So we have blended learning, which is basically a mix of both in-person as well as e-learning kind of stuff. And as part of that blended learning, as part of the e-learning, we have multitude of mediums by which we communicate, which is basically talking about having high quality videos or having podcasts or webinars. And one of them we are going through today as such. So again, the net goal is we focus on technology, we stay ahead of the curve, and we deliver it in small bite size and in the bite size, which is relatable as well as current to the medium or preferred medium of acceptance of the data. So that's what is a short introduction about award. As I said, it's going to be around an hour session. So my request is please mute the line. Questions are welcome, put it out on the chat. The last 10 minutes or so, we will take up some of those questions. And as I said, if in case we are not able to pick up all the questions, we will respond back. Little bit about myself before I jump into the content. My name is Bhupinder Bajwa. I'm an SME at Award. Have decent time in the industry, all of it wireless, and work through different portfolios, different responsibilities, and also work through different OEMs as well as carriers in the market. Current focus is 5G and LTE and on the RAN side of the house. This is what we're going to talk today. So let me get back to the content. So as I said, it's a complimentary webinar. We're trying to build a high-level overview of what is 5G. And as part of that, we are going to talk about performance requirements of 5G, what is driving 5G. We're going to talk about what are the building blocks. So once we define what is 5G, once we define what the requirements are from 5G perspective, and then we're going to talk about a little bit at a higher level, what are the building blocks of 5G. And while we talk about the building blocks of 5G, we're also going to talk about where is 3GPP at this point of time. So when we look at 3GPP roadmap from a standardization perspective, we'll talk a little bit about release 15 and release 16. 15 is where we are today, and 16 is where we are heading next. That's the next release up in the pipe. While we talk through that, we'll give a short overview of different entities and organizations which are involved in this whole process of defining the requirements, putting the standardization, and so on. So that builds us enough perspective to start diving into the individual areas of our interest or our responsibility as we may be interested in going in post this session as such. So as far as the course goes, we are going to focus on these three areas, which is basically talk about how things are organized from a standard body as well as alliances perspective. We are going to talk about the 3GPP roadmap. And finally, we are going to talk about the building blocks of 5G and a high-level reference network architecture from a 5G perspective. So fundamentally, what we say is there are three different blocks. The Next Generation Mobile Network Alliance, that's one of them, which is again an industry body, which is trying to build what are the use cases, what are the business models, or what are the value creation proposition which is going to come into play from 5G perspective. And they have also been talking about LTE Advanced and so on. So this is the body, which is an industry body, which is involved in putting together what would be the key requirements, use cases, business models, and value creations. As part of that, and again, you'll see all the key players are part of the NGMN, which is the Next Generation Mobile Network. And what you see there is the definitions of what is the use case. We talk about user experience. When it comes to user experience, we are saying 5G as part of NGMN, the expectation is it's going to be much higher data rates, much higher area capacity, much lower latencies, and availability throughout and the availability is going to be much higher. So those are the fundamental goals, and they are sort of put forward by this alliance saying this is what we should be looking forward from our 5G perspective. While talking about that, they also want to talk about what are the different business models in the context of saying traditional play of voice data to our users or customers is one part of the story. Then we need to start looking at beyond that in the context of saying beyond our existing customer, what else is going to open up? What are the different partnerships which we can create in the industry and in turn drive newer business models? Example is going to be the most talked about example right now is going to be the automobile industry, which is basically talking about V2X, connected devices, and so on. So this is what is the body which is getting into that part of the discussion. Enhanced services, which is basically saying enhanced use cases. While we build the enhanced use cases, while we build the partnerships, then we want to talk about, NGMN is also talking about enhanced services in the context of saying we can, as a carrier, you can talk about a carrier as an infrastructure as a service, or they can be talking about different use cases as a service, or different, basically, the bottom line is we are trying to say we want to monetize the network, go beyond just the traditional voice and beyond the traditional voice and data services to our retail users. So we are talking about either we talk about providing infrastructure as a service, we want to talk about network as a service, or we want to talk about platform as a service. So all those models are being talked through this particular entity. While that said, system performance targets. So, which is basically saying what is going to be 5G in the context of saying higher throughput is good, but then what are the kind of performance targets we want to build around that? Lower latency is great, but what is the performance target around that? So those are the things which are coming out of this NGMN alliance, and which is sort of getting into the ITU domain of saying this is what is the performance target we are going to set for 5G, and then from a standardization perspective saying these are the business models we need to support, and we need to put the solutions or the network architectures in play to do that. Efficient and flexible network and scalable network. So that's another theme which we are going to see as part of 5G all along. So that's again coming back from the industry sources saying, while we want to open up newer partnerships, while we want to open up newer services, While you do that, we want to ride it on the same network. So it has to be flexible, it has to be scalable, and it has to be efficient as usual. At the same time, they're talking about different devices, different capabilities of the devices which needs to come in. So all that is coming in from the NGMN. While NGMN is the industry alliance, and then you have the ITU, which has basically defined, and some of this is going into the ITU discussions also. So basically what they are defining is what are the use cases. So when it comes to 5G, fundamentally, there are three pillars of the usage scenarios which have been defined by ITU. And as part of that, the first pillar is referred to as EMBB, Enhanced Mobile Broadband. And as the name suggests, the focus in this particular case is basically high area capacity as well as peak data rate. So it's basically throughput. It's basically saying user experience enhancements in terms of peak data rates, as well as area capacity enhancements in terms of how much capacity I can build in a given area. So that's the focus. That's the fundamental pillar of EMBB. Now, EMBB is a usage scenario under which you may have different services which are going to fold in. Different services can be, you can be streaming 8K videos, you can be playing and working and playing in cloud. All those are services and usages. While the underlying principle or the underlying pillar under which ITU has defined it is EMBB. Similarly, ITU has defined the second pillar for 5G usage scenario. And the second pillar, as the name suggests, ultra reliable, low latency communication, URLLC. So that's the second usage scenario as defined by ITU for 5G. And as the name suggests, low latency as well as high reliability, then we can keep talking about what services are going to get folded under this pillar. So this is the second pillar. Services can be self-driving car, services can be factory automation, services can be any robotics, which we can think of. So all that is going to be the services or usages, but underlying usage scenario is URLLC. The third pillar, as defined by ITU, is massive machine type communication, which is basically saying high connection density of devices which have very low data requirements, and at the same time, they may not have very high reliability or latency constraints as such. So in turn, these are the three fundamental pillars as defined by ITU for 5G usage scenarios. Around this, what they've gone ahead and done also, and this is ITU, has gone ahead and defined what should be the performance target for these usage scenarios. So first is saying these are the fundamental three pillars. All these three pillars are looking in three different directions. One is looking for high data rates, second one is looking for high reliability, low latency, and the third one is looking for connection density. While we flow in all these three pillars, they've defined what the performance target should be. And this is again part of the requirement. So again, what they have done is when they said peak data rate, the expectation is an ideal condition, single user, whatever resource you're going to pump into the network, expectation is you're going to have a downlink peak data rates of around 20 Gbps, uplink of 10. Similarly, for low latency services, they're looking at a RAN latency under 1 millisecond. Number of connected devices from an MMTC perspective or a massive machine type communication perspective or an IoT perspective, they're talking about 1 million devices per square kilometer. That's the kind of density. At the same time, we are saying enhanced mobile broadband. So we want to enhance the user experience. So high availability and consistent user performance throughout the cell. So as part of that, they've also gone ahead and defined cell edge data rate. Now, when it is cell edge, it means throughout the cell, at least we are talking about delivering 100 Mbps downlink throughput for a given user. And similarly, for a user, uplink 50 Mbps. So again, what ITU has done is they've defined the fundamental usage scenarios. And around those, they have defined what should be the performance target. Around that, they've said cell throughput. So area capacity, cell throughput, they're talking about 10 Mbps per square meter. That is the kind of performance they expect while we talk about 5G. If you look at the IMT 2020 map, or IMT 2020 presentation, and if you compare it with IMT Advanced, which was the previous release, they're talking about, if you look at this user experience at the data rate, we are talking about 100 Mbps in the downlink, which used to be around 10 Mbps before. They're talking about mobility speeds, which used to be around 350 kilometers before. Now they're talking about 500 kilometers. That's the kind of speed we need to support from a mobility perspective. Latency, RAN latency was around 10 milliseconds before, and now we are expecting it to be under 1 millisecond. So that is the order by which they're pushing the envelope in the context of saying 5G is going to be newer, enhanced services. And while we are enhancing those services, the performance targets have to be much higher compared to what we were doing before. And if I can take one more example, which is basically saying the connection density. It used to be around 100,000 connected devices per square kilometer. Now they have moved it up to 1 million. And again, if you look at the energy efficiency, that's another area which is going to be of high focus. They're saying energy efficiency of 100 times is the target, is the goal. So that's basically coming out of IMT 2020, which is again driven by ITU, which is basically saying this is what we want to do as far as 5G goes. So first theme, NGMN, building all the use cases, building cases beyond what we have been doing so far, and also enhancing the experience of the existing users. Second, folding it into the ITU requirements in terms of saying usage scenarios, 3 fundamental pillars, and around that, the performance targets. And then it goes to 3GPP to put the standards in place, put the solutions in place to meet these targets. That is what is underlying 5G requirements, 5G target, 5G vision as such. So when it comes to 3GPP, and again, let me pause here. Questions are welcome. As I said, at the end of the class, I'll be taking around 10 plus minutes, hopefully. We'll have that time. So feel free to drop the questions on the chat so that it can be picked up later. Thank you. 3GPP roadmap. So now that we understand the bodies in GMN and then the ITU, and now let's look at the 3GPP. And 3GPP, when you look at the standardization roadmap from a 3GPP perspective, we can go all the way back to the start of this 2000, which is basically saying R99, if you remember, UMTS. And that is where we started. We talked about packet services. We talked about 2 Mbps. 2 Mbps was great at that point of time. And now we're talking about peak data rates of 20 Gbps. That's the level or movement which we have had in the last 2 decades. When it comes to 5G, we are talking about, and again, we can keep talking about looking backward. Looking backward, release 8 was the first release where we switched from UMTS to LTE. And then in release 10, we had moved to LTE Advanced, and that was basically looking forward towards IMT Advanced targets. And IMT Advanced targets, then there, we were talking about higher order MIMO, we were talking about carrier aggregation up to 100 megahertz channel bandwidth, 100 megahertz carrier aggregation up to 100 megahertz of spectrum, still keeping 20 megahertz as a limit on the channel bandwidth. So all that while it is flowing, IMT 2020 comes in as precursor to what is the requirement from 5G perspective. And from a 5G perspective, our first release of 5G is release 15. This is where we are today. This is the release which is in talk, in implementation as we speak today. As we go into 2020, we'll have the follow-up release, release 16, and release 16 should be there by Q2 of 2020. And then release 17 is in the early stage of discussion. What is going to get folded into the work schedule of release 17? Sometime in Q1 2020, they are going to freeze what is the areas, work areas they are going to work through it, and then look at a window of 15 to 18 months before we have release 17 coming out. So somewhere in that 2021, late 2021 window is where we are expecting release 17 to be out. Release 18 is there as a marker, but there are no discussions around at this point what is going to come there. Focus is 16, freeze and release by next year. And then sometime end of 2021, you should start seeing release 17 coming out, which is basically going to be the next release from 5G perspective. As we speak today, everything is pivoted on release 15. So what we are looking at today, all the deployments, all the actions, all the discussions are around release 15, while release 16 is coming soon. While looking at the roadmap from a 5G perspective, what is the key highlights of release 15? From a release 15 perspective, what we are seeing is release 15 supports both standalone deployment of the network, which is SA, and non-standalone deployment of the network, so which is NSA. And while that's it, the new air interface which we are using for 5G, and that's referred to as new radio. So release 15 covers the deployment details of new radio. Release 15 covers standalone deployment as well as non-standalone deployment. Now, release 15, from a deployment perspective, it has multiple deployment options, network deployment options. It runs from 2 to 7, and there are different combinations of what is possible within that. So it supports both. Release 15 supports both standalone as well as non-standalone. And release 15, when we start talking about 5G core, we are looking at a totally new core network architecture. We're looking at a service-based architecture, which is totally new concept in terms of wireless, in terms of 5G core. So release 15 covers the service-based architecture of 5G core, which is what we will see come 2020, deployment of 5G core. And that time we are talking about service-based network architecture for the core network for 5G. Release 15 covers the network slicing part of it. Now remember, the usage scenarios are pulling us in 3 different directions: eMBB, URLLC, MMTC. All 3 are having 3 different requirements. It's like my child. One wants to play soccer, another wants to play basketball, and the third wants to play baseball. So all 3 are pulling in 3 different directions. All 3 are sports. So that is what is going to cover as part of network slicing. It's basically saying I'll create pipes where I can ride these services individually, map the QoS requirements, map their policy and control functions, and all those things in the 5G network. So network slicing, again, it is covered as part of release 15. Multi-access edge computing, absolutely given as part of 5G rollouts, and that's very much well-defined and covered as part of release 15, where we are saying we'll take the processing to the edge. We'll take the user plane, some of the user plane functionalities closer to the edge, closer to the user. And the driver, low latency. Driver, more efficient use of network. So that's again covered as part of release 15. And at the same time, we have interworking of the EPS, which is the current 4G network core asset. So that's what is covered as part of release 15 as we speak, both standalone and non-standalone. Today, deployments are in progress in all the bands as you can see it. A lot of action on the high band in our markets. Mid band, again, we are seeing action. Low band, we are seeing action. More you'll see in the sub 7 gig come 2020. We are seeing use cases both on fixed wireless and mobile. And while that's said, when we move on to release 16, that's what is coming next, which is basically the freeze is expected in Q1 and the formal release with the ANSI details by Q2. And the focus there, unlicensed spectrum. So add more spectrum in unlicensed band to cover LAA, as well as non-assisted unlicensed operations of 5G. Focus again is one vertical, which is basically V2X, vehicle to other devices. So that's again a focus area for release 16. Satellite communication, terrestrial, non-terrestrial kind of communication. So that's again part of release 15 focus. Release 15 is big again on URLLC and MMTC, massive machine type communication. And what you will see, a combination of 2, factory automation kind of IoT devices with high reliability, high low latency kind of services. That's another area of focus for release 16. So release 16 in nutshell, what is the focus is more near band, unlicensed band, both LAA, non-LAA operations, V2X communication, and non-terrestrial communication. While that said, IoT from a factory automation perspective. That's where the focus is of release 16. Release 17, as I said, last when we were looking at the details from an industry perspective, a lot of the pre-inputs have been taken in, and sometime Q4 of this year and Q1 of next year, 2020, they're going to harmonize and then take a call. What is that they want to follow? And that once it is frozen, then the work area starts. And that's where, as I said, the window is another 15 to 18 months from there. So that's where we are in terms of saying where 3GPP as well as the standard goes. So we are saying release 15 is where we are. Release 16 is getting done early next year. And there the focus is, again, more spectrum, newer bands, more V2X kind of operations, and more factory automation, IoT kind of services, which are low data rates, but high on reliability, and again, low on latency. Let's look at what are the building blocks of 5G. So the key building blocks of 5G, which will bring in the underlying theme, what is playing out. Now we know what is the usage scenario, what is the driver for 5G. We know what the requirements are from that driver perspective. And then let's look at it, and we know where we stand in terms of the standards. Let's look at what are the key building blocks. So when you look at the key building blocks, this is a good slide, which gives you a good high-level insight of saying what is changing. So when you look at it from the air interface perspective, we are able to support much larger channel bandwidths. When it comes to 5G, we are talking about channel bandwidths as low as 5 megahertz. And when it goes to the millimeter wave or the frequency range 2, it can go up to 400 megahertz channel bandwidths. So we are saying much bigger channel bandwidths. At the same time, we are saying we support all the existing bands, which is the low, the mid, and then we have introduced new frequency band for operation, which is basically also referred to as frequency range 2, which is your millimeter wave. And the moment we do that, we have opened up a big chunk of spectrum out there. So we are talking about 28 gigahertz, we are talking about 39 gigahertz, and we are talking about spectrum as big as 3 gig in 28, 3 gig in 39. And when we start looking at the future releases, 16 and on, we'll see more spectrum coming in, newer bands coming in. So newer spectrums are getting introduced as part of 5G deployments. Beamforming and MIMO, big theme as far as 5G goes. So on the air interface, we are saying we are going to be beamforming, and we are going to have higher order MIMO. So again, improves the performance of the network, improves the capacity of the network. So that's coming in 5G as far as the air interface goes. And a very important concept, flexible frame structure. We are talking about flexible subcarrier spacing. We're talking about flexible TTI for scheduling resources in the time domain. And we are talking about flexible concept of bandwidth parts. So totally new concept in terms of how we organize resources in 5G. And that in turn on the air interface is going to bring in efficiencies, is going to bring in improvements as such. So that's coming on the 5G side on the air interface. When it comes to core, the key theme there is virtualization. Very big play on the core side. And the key theme there on virtualization is basically saying a lot of network function virtualization, software-defined network, and separation of the control plane from the user plane. Separation of the hardware from the software. If you can remember these buzzwords, you're good for the coffee machine discussions, which is basically saying the key underlying theme when it comes to 5G core is virtualization. To drive virtualization, NFV, SDN. While we do that, the goal is separate the hardware from software. The goal is separate the control plane from the user plane. And the moment you are able to build that reference network architecture for core network with that theme, then it opens up a lot of gates. Then it opens up gates in the context of saying we can do slicing. It opens up the gates in the context of saying I can do a multi-access edge computing and take some of those user plane services, user plane applications, user plane functions closer to the edge. So all that opens up by doing this virtualization. So that is the key story as far as 5G core goes. And that in turn is going to help us do network slicing. That in turn is going to help us do edge computing. And that in turn is going to help us how we place resources, how we configure resources, how we respond to changes in the networks, and so on. So that's part of the 5G core changes. The virtualization theme is going to play out on the RAN side also. And that's again part of 5G story. And what is happening is, again, virtualization both in the core and in the RAN. And on the RAN, you will see a lot of discussions on split RAN architecture. There are multiple RAN split options which we can deploy on the architecture side, on the RAN architecture side. And option 2 is one of the key ones being discussed as part of 3GPP release 15. And as part of that, we are saying the baseband, we are going to split it into 2. We're going to have a central unit and we are going to have a distributed unit. And the central unit is going to handle some of the higher layers of the protocol stack. And in turn, they are going to be less delay sensitive, it can be more into virtualization. And there the theme is, again, the central unit is going to be more cloudified, is going to be more virtualized. So split RAN architecture is another story which is going to play out as part of 5G. While I make a statement saying split RAN is one of the key story of 5G, that does not mean that we are not going to have CRAN, we are not going to have distributed RAN, what we have today. You'll have a portfolio of RAN architecture, but from a 5G perspective, we will see more push and drive towards split RAN over time as we see. So that's again playing out as part of 5G network building block. So key building blocks on the radios, on the RAN, and on the core. While those are the key highlights on the building blocks from a 5G perspective, when it comes to where we are today and how are we going to move forward and introduce 5G and then over time migrate into a full-blown 5G, network deployment options, there are multiple options. As I said, we have option 2 all the way to 7. But what we are seeing today as we speak, we have our traditional LTE deployments where you have the LTE core, you have the eNode Bs talking to each other on the X2 interfaces, and then back to the core through the S1 MME for the control plane and the S1U for the user plane. And then you have the air interface, which is the LTE air interface talking to the device. This is our world as we speak today, and which is rapidly changing wherever we are seeing 5G deployments. And all the existing 5G deployments, at least for 2019, what we are seeing are in non-standalone mode. And to be specific within that, what we are seeing action is option 3X. So one of the deployment option is option 3X, and we are seeing non-standalone deployment of the network, option 3X. And what does it mean to us? What it means is this particular device, which is 5G ready, is capable of talking to both 5G and the LTE network at the same time. This particular device, which is 5G ready, can talk to the LTE and the 5G network at the same time while I still use my 5G LTE core. I still use my LTE EPC. While I'm using my LTE EPC, the communication between the RAN and the core, the control plane communication is only happening on LTE. The user plane communication can be happening both on the eNode B as well as the GNB, which is the 5G node, which is the 5G RAN. So basically we are saying control signaling happening on eNode B towards the core, and the user plane can still talk to the core between the 5G node as well as the EPC. At the same time, we still have the X2 links between the eNode B and the GNB, and both control plane as well as the user plane. When it comes to the air interface, we do not have the signaling link. We do not have the RRC for call control out there on the air interface on the GNB. What we have is only the user plane connectivity. This is what is option 3X. This is what is happening today as we speak. And while we say that from an ITU perspective, from the usage scenario perspective, the only usage scenario which we are focusing at this point of time is EMBB. That is what we are doing today. Come 2020, we will see the 5G core getting ready, And we are already seeing some early testing and other stuff happening. And when the 5G core is in play, then if we have a 5G device, which is capable of using 5G air interface, which is the new radio, then you'll have an end-to-end 5G. And that's where we are saying we'll have a 5G RAN, you'll have a 5G core, and a device which can talk the language of 5G. That's going to be standalone. That's again option 2. Now, 2020 is when we are expecting some of this field deployments of standalone possible. That does not mean that every carrier is going to jump on that wagon and start deploying standalone. You will see multiple migration stories panning out, carrier to carrier, markets to market, depending on what their plans are, what strategies the carriers apply. So network deployment options, there are going to be multiple. Option 3X is where everybody is there today. Option 2 is going to be feasible start next year. And finally, what is the migration path? It's going to be very carrier specific. It's going to be very specific to the strategy of the carrier. While that said, on the RAN side, we are saying again, the migrationary path towards 5G over time is going to be, we have the current LTE where we have the antennas, we have the radio, and we have the BBU, which carry all the higher layers, which is what we have been connecting through the coax, through the BBU to the radio. And then we had the backhaul, Ethernet backhaul going back to the core. We moved into the CRAN, and CRAN is, again, you'll see all the 3 flavor to start with. Over time, we say that the 5G RAN is going to go more into the split RAN mode. So CRAN, what we have been doing is still the antennas, the radios, and then we had the front haul, which was a CIPRI, and going to the BBU, which used to be in the hub site. And then again, the backhaul from the hub site to the core. We are seeing some deployments in this mode also. And then we are expecting to go into the split RAN architecture, where we are saying we are going to still, and a lot of cases you will find integrated antennas and radio. And then you'll see the lower layer, the DU, handling the lower layer, the physical, the MAC and the RLC, and they going closer to the radio. And you will see the higher layer, the PDCP, the RRC, and the SDAP coming to the, which is also called as the central unit, getting closer to the core. So this is getting closer to the core, and this is getting closer to the radio. The whole goal is process intensive, delay sensitive, take it close to the radio. Things which can be not delay sensitive, which can be handled much better at the back. Then this is where the virtualization story will start first. And this is what is going to be part of the RAN network architecture when you get into 5G. We have been talking a lot about millimeter wave. We have been talking about opening up new band. And one of the key band which has been opened up as part of 5G has been frequency range 2, which has been the 28 gig and the 39 gig. And as part of that, the key benefit of this particular band, and there are challenges also, but the key benefit is the pipe size, the kind of spectrum they have, huge, much larger. We can go up to a channel bandwidth of 400 megahertz in this particular band, and the amount of spectrum available is around 3 gig in 28 gig, and another 3 gig in 39 gig. So that's the amount of spectrum we have opened up by just going into that band. At the same time, the physics of this particular band is also very helpful to us, which is basically saying the antenna sizes are very small. So we see hundreds of elements coming into the box. And you'll see integrated box, which has the radio and the antennas together. So in turn, that opens up the possibility of doing those very nice beamforming. Because of hundreds of elements, we can group and do all those fancy beamforming stuff are coming out of that. And in turn, improve the performance from high gain, better SINRs, lower interferences. But at the same time, because the propagation behavior of this band is very challenging, we will see much smaller coverages coming out of these bands. So in turn, very small cell sizes, very small cell sizes. So in turn, small cell sizes with much higher capacity, very challenging in that context to leverage all the capacity which we have created. So again, big play. And again, most of this play, at least for now, is focused on eMBB, broadband services. And we are seeing a lot of deployment of this in the context of saying capacity hotspots and so on. When it comes to core, the underlying theme was virtualization, as I was saying. And the key theme there is basically separation of the user plane and the control plane. So these are the underlying themes which are playing out, and then you can put that orchestration of end-to-end story together. So first is separation of control and user plane. Second is making it a stateless network function. So which basically says control plane is not holding the state of the network. So states are stored, and in turn, the control plane processing computing can be done on cloud. At the same time, it helps in a better way of managing our recovery and disaster recovery and so on. The third theme we said is service-based architecture. So we are saying service-based architecture, which is basically saying very modular and very software-driven approach to the whole concept. And then we are saying edge computing, where we are taking some of the user plane functionality or applications closer to the edge. In turn, we are reducing the latency. In turn, we are reducing the amount of resources which would be required on the transport network to carry it back all the way to the core. So very localized and central access. Now, while we do that, we can still have those centralized processing happening while certain functions can go closer to the edge. So underlying theme which is playing out is basically saying service-based architecture, separation of control plane and user plane, stateless functions, and edge computing, and also SDN, NFV, and SDN. The whole underlying theme, while we talk all that state, while we are talking about flexible air interface structure, we are talking split RAN, while we are talking virtualization on the core, the underlying theme is I should be able to create a slice of the network end to end. And when I create a slice of the network end to end, my backend thought is that 3 usage scenarios which ITU has defined, which are EMBB, URLLC, MMTC. So I should be able to write them in each of these pipes or each of these slices independently, manage the QoSs for those slices, manage the policy and control functions for those slices. And while doing that, they are so virtualized, they are so software driven that it gives me the agility to reconfigure resources much faster. It gives me the agility and ability to keep very optimal use of resources, wherein we are saying we can reconfigure resources based on the usages, based on the requirements, and we can respond much faster. So that's the underlying theme of 5G network, which is basically create the ability to create a slice. And again, slices, I'm talking in the context of different usage scenarios. You can also refer as slices within a particular usage scenarios. Different partners, you may have different understanding. So let's say that you're doing a V2X kind of stuff operations, which is basically saying autonomous cars, and you may have different partners. You may have Toyota, you may have Ford, you may have Tesla. So you may have different requirements, different commitments. So you can create slices of the network end to end, and you can be the network service provider. Network as a service, you can sell it to them. So again, this is the ability which 5G is going to bring into us. When it comes to the edge computing part, we are saying we have separated the control and the user plane. And what we can do is we can handle things locally for certain applications. And how do we do that? We are saying the user plane functions of the core, as they are all software, they are separated from the control plane. I can just move some of those functionality into some servers which are closer to the radio. On the contrary, it can be on the same server where I am running the CU plus the UPF. And in turn, I can do the edge computing. I can hand it over to the multi-access edge computing platform. In turn, some services, local streaming, local gaming, and all those stuff can be handled much easily, much seamlessly. While that said, I still have my core network where I'm processing the control plane. While I still have the user plane functionality for some other services, for other applications, which may be at the centralized location. This is what brings in the flexibility. So this is like basically the MEC and the 5G. We have been talking about MEC in the LTE world also. So both put together are making a nice play for us for some of those services which are delay sensitive, some of those services which can be run on the edge, some of those services which can bring efficiency in terms of network resources, how we use them. That's 5G. When we look at 5G in a broader context, where we have moved from LTE, LTE is the first window where we moved into all packet. We moved into all packet network, and now we are saying we're going to move into all virtualized network. We are going to move into two key themes, which is virtualization and the other key theme of 5G is going to be flexibility. We can talk about what are the underlying pieces which are bringing in the flexibility as well as virtualization in different areas, in the air interface, in the RAN, in the core, but the underlying theme, the big shift from packet, when we come to 5G, we are saying it's all packet, but at the same time, we are looking at virtualization and we are looking at flexibility in how we configure any of these resources. That's the underlying takeaway theme of 5G. As we said, we can have edge computing, and while we do edge computing, we can be doing all cloud-based for both the RAN and the UPF sitting on the same platform, same blade server, closer to the radio. And again, the core functions, again, are going to be cloudified or virtualized, whatever may be the configuration or solution the carriers may decide. In a broader sense, what does it mean? If you're a RAN person, what does it mean to you on 5G? Broadly, our sense is basically what it means is the staff sizes may still stay the same. You may not see another wave of saying big increase in the staff size, but what will happen is the number of network elements may go up while you're managing more network resources, more complex network configurations. So in turn, from a RAN perspective, we strongly feel that you'll be more focused on getting into automation, improve automations to improve productivity and key skills around that. So that is the area where you would be looking at. While that said, on a RAN per se from a 5G perspective, we are looking at newer devices coming into the network. You're looking at a newer air interface, which will be in different bands. And again, you'll see a lot of TDD being deployed, especially millimeter wave is all TDD. Most of the 3 gig and above is all TDD. Some of the lower sub 3 gig also is TDD. So you'll see many more combinations of frequency bands. So layer management, start thinking in that context. Look at beamforming. That's going to be the big play. So while whether we are in millimeter wave, whether we are in sub 7 gig, both cases, you're going to look at a lot of beamforming happening. And then you're looking at virtualization as well as split RAN configurations, which are going to get deployed. So if you're a RAN person, you start looking at it. Now I have a split configuration, I have a virtualized configurations. So some of those areas which you'll start looking at it. And then the transport network is going to play a big role because the kind of pipe sizes we are talking about now are huge. When we start talking about delivering transport for the millimeter wave and so on, the kind of transport requirements are huge. So some of that stuff is going to play out. So when you put all that pieces together, it's basically saying same staff size handling much more part of the network, much more complex networks. And key theme is going to be automate most of our productivities is going to be the key new skill, which you will be focusing on. When it comes to the core, the key theme is going to be orchestration, because we are saying everything is virtualized. Everything is virtualized. I can put the pieces in different places. I can put the pieces in the cloud. I can put the pieces on the virtual software with using a commercial hardware, and everything is going to be sliced. And the slice has to be agile. The slice has to be reconfigurable. So when you start thinking in that context, what are we looking at? Somebody has to play that symphony. Somebody has to drive that as a conductor of the orchestra. So a lot of orchestration stuff. So basically we are saying operating in the cloud environment. So codifying the engineering process. This is what we use the term as codifying the engineering process into orchestration script, which is basically saying, how do I want these resources to be configured? How do I want that agile reconfiguration of resources? How do I want the slices to be done? How do I want to make sure that they are dynamically reconfigurable? So all that is going to be part of the core engineer's responsibility. And that is the new skill set, what the core engineer will be focusing on as we go forward into 5G as such. So in nutshell, now let me bring in the value proposition from award perspective, what we bring on the table to help the teams to step up and get ready for the industry as we go. So I would say 2019 has been that initial year of seeing some push towards 5G, and 2020 is going to be a key year in terms of 5G deployment. And the way we structure, as we said, we are the leaders in terms of technology training. At the same time, we understand how to slice it, keep it at different levels. And so again, we set different models. So same theme here. So we have foundation courses, which are primers. We have detailed courses, which are very in-depth, both in design. If you start looking at signaling and operations, we talk about logs and other stuff. So we have the complete portfolio in the context of saying how big or how small you want to get into understanding the underlying themes as such. I'll close by saying that there is an upcoming tech primer, which is, again, I would strongly recommend for folks who are into network side of the house, which is basically talking about 5G services and network architecture. It's coming up on 10th of December. And again, thanks for you to participate this particular webinar. You get a free 40% on that as such. So make good of that. And again, follow-up questions are welcome. So again, don't stop your communication with us. We are very open to receiving follow-up questions. And in turn, we'll be very open to respond back as such to any follow-up questions you may have. And that's about what I had for the webinar. And again, I see one question, which is from Raju. Thanks, Raju, for the question. So example of V2X, right now, again, we are in that early stage, I would say, because right now, remember, Raju, so let me just set the stage first. Right now, today, what is going on is option 3X, which is basically saying only one usage scenario, which is everybody is focusing on. It is eMBB, broadband services. Come 5G core, then you're going to start talking about V2X kind of services. And in V2X kind of services, they are talking about multitude of possibilities. Multitude of possibilities is basically saying to the extent, if I can just expand. So there is no specific example which is in play in the field as we speak. But if I can expand to that, is basically saying vehicle to vehicle communication. It's basically saying vehicle to the embedded environment communication. So it's basically very dynamic communication with the environment which you have. And if I can give you a highlight, we are seeing some testings. Some of these big players are in that internal control testing in some of these domains, but it will be more of saying vehicle to vehicle, vehicle to embedded environment, like let's say the light pole, communication with that, or let's say the traffic, basically traffic flow coming back to the vehicles as such. So some of those domains are where we are going to see some traction as such. We are definitely not expecting the Tesla to be driven based on 5G at this point of time. It's still going to be on the onboard processor, what is running right at this point of time. But over time, you will start seeing more and more communication to the environment, communication to the devices, and communication. It's more of vehicle to other vehicle or vehicle to other machine, which is the communication we are looking at in the context of V2X. Hope that helps. Any other follow-up questions? All right, so if not, thank you very much. Appreciate your time. And again, do follow us both on Twitter as well as LinkedIn. And always feel free to reply back if you have any follow-up questions. Again, this is recorded session, so it will get posted. You will get a detail of where to go and look for information. And that's about what we had. Thank you very much and have a wonderful day.